The slides are getting loaded. And you'll have the microphone. Oh, we're streaming. OK. So you can use this microphone. You can get on stage. Since we're streaming, this, for the people watching us back home, there has been a whole 2 days of conversations that were not in this room, were next room, not on camera, so that people can speak freely about their ideas. And we asked this standardization working group to kindly come and present to us, the future viewers, current people in this room, what exactly was happening next door, and what are the conclusions or what they worked on. And also how ZKProof in general functions in terms of doing standards. So I'm happy to invite the three of you. Come the three, and then one after the other. Michele, Mary, and Ying, Tong will present each what was happening over there. Go ahead.
Hello. 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 So, yeah, how are you feeling?
All right.
You're dead. OK. So why are we here? Why are you here? I think we all kind of like ZKP for different reasons, and a lot of people are also growing businesses around these things. And however, there is a little problem, right? That it's still sort of a niche topic that not everybody in the world well understands, or even less engineers that can code it are sort of rare, and they're very expensive. And you know, so we're here to try to specify these things and try to make sure that they, at some point, are sort of auditable by people and can be read by anyone. And for this reason, we have a bunch of working groups. And you know, if this working group don't succeed, I don't know if all these startups will have a long way to go in the next 10 years or so. So I think this work is crucial, and your input, especially if you have already tried to implement all these ZKPs and played with little corner cases, your input is particularly valuable for us. And so, yeah, for our approach, I think, is to sort of encourage adoption, try to formalize things, and try to sort of sediment the literature, summarizing the papers and the knowledge that we have about it, both in practice and in theory. And yeah, I think over the years, this procedure has sort of crystallized, and I think Mary has done a great job at this, and so I think she will also explain how this is going.
Okay, forgive me if I'm reading my slides a little bit. On the slide, you can see a QR code. This QR code is linking to the ZKProof website, and in particular, a subpage on the ZKProof website, which is telling you the process both for creating a working group and for maintaining a working group. The ZKProof Standards Committee, who are really overseeing these working groups, was formed in 2023 to develop the process for community promotion and promotion of specifications and standards, and to oversee the creation of corresponding working groups. These processes are in the early stage of implementation, so they are subject to change, but we are working with system that we think should hopefully create exactly the right barriers for creating more working groups, such that the people who do create them want to create them, mean to create them, want to be involved, want to participate, but at the same time, not so much as to close it off and make it so that only certain people can participate. We definitely don't want to do that. The processes, yeah, will be adaptable to integrate learnings. I've taken what we've written about how to submit an abstract, which is the first thing you would need to do if you wanted to create a new working group, from the ZKProof webpage. I've also removed a ton of text because it's on a slide, and I didn't want to have a slide that was too full, it's still quite full. So if there's some things here which are maybe a little bit less formal than you'll see on the webpage, that's why. The abstract submission, what you need to do is propose an abstract to the ZKProof Standards Committee that includes the title of the working group, the team that's involved, and a public contact address. Also a working group liaison, and this is just one member who's responsible for keeping the Standards Committee aware of relevant updates. The structure of this abstract, we would like to see an expected structure of the future initial draft specification. Obviously, this is what you think the specification will look like at the start of the process, so we know that this could change. A planned time frame. Expected complementary documentation, so this includes open source reference implementation, test vectors, and code instructions, and also any references. Once you've submitted your abstract, there'll be a process of review/approval. So upon internal analysis, the Standards Committee will seek initial advisory opinion. This will be both from the editors and the steering committee. And they will then follow up either with an approval, possibly with some suggestions, or with a request for improvement or adjustment based on the provided feedback. And any revisions later to the abstract will follow the same process. Once the abstract has been submitted and approved, you will then be invited to present the abstract at some ZKProof event. And the reason that we would do this is so that you can advertise your work, maybe the fact that you want other people involved, maybe what's going on with it to other people in the ZKProof community. Okay. Once a working group is created, this is an outline of the process, again, with lots of text removed, but I still think too much text for me to go through in all of its detail. So I'm just going to say the things in bold. You need a public abstract, a Z-spec proposal, which will later become a Z-spec draft, which will later become a Z call for comments, which will hopefully later become an approved Z-spec, but you might have to go through the first 3 steps multiple times, which will finally become a Z-spec publication. And then there will be updated versions which will follow a similar process. Okay, that's all I really want to say about the process, and the reason I covered it here is because you're all captured, so sorry about that. Regarding yesterday, I'm going to be talking about the Plonkish Working Group conclusions, and after that I will follow up with Ying, Tong, and Michele to talk about their groups. Just briefly, what is the Plonkish Working Group? An arithmetization is a language that a proof system uses to express statements, and a circuit is a program in this language. The primary purpose of the Plonkish Working Group is to specify a particular arithmetization, namely the Plonkish arithmetization that is used in the Halo 2 proving system. We want to cover both a simple version of this arithmetization, which is hopefully comprehensible to developers. At the same time, we would also like to include as many optimizations as we possibly can, and we're kind of separating these 2 goals in order to make our job doable.
Question, is this an example, can we find examples of the previous process through the Plonkish Working Group?
Yes.
Okay, thank you.
Here's a link.
Oh, amazing.
So the Plonkish Working Group has a public repository. This went public a couple of days before ZKProof, which is no coincidence. In this repository, you'll find the working group abstract, which if you're thinking about proposing your own abstract, could provide a good example. Also, you will find an initial draft, and I'm calling it an initial draft here because it's not been submitted yet, of a Z-spec proposal for a simple Plonkish relation with no shift or rotation constraints or row orderings. And I'm not going to explain the jargon. We did explain it to the people that were there yesterday, but hopefully some of you know what I mean. Also, you'll see a started C-spec proposal for the optimized Plonkish relation. This is not nearly ready yet, so expect it to not make much sense. And finally, we have some placeholder links for reference implementations. During yesterday's working session, there are some notes which were taken by Ying, Tong. Thank you very much. What we did is we walked through the simpler relation spec in lots of detail and which highlighted areas which were poorly explained. Certainly there were cases when we saw lots of very confused faces, and we recognized when we saw the confused faces that maybe we needed to work on those sections. And also we did spot some typos and even bugs while we were at it. We also briefly showed the work in progress that we have on the optimized relation. We spent less time on this, mostly because we saved it until the end of the session and then ran out of time. And we discussed the challenges involved there. Regarding actionables, we learned that we need to generalize the equivalence relation. Again, don't worry if you don't know what I mean there. And that multivariate polynomial outputs should be vectors. Yes, for lookups specifically. Thank you. Some conclusions from yesterday. The first is regarding rotations, which are an optimization that we were hoping to include. Rotations are an alternative to copy constraints that can be more efficient, and they are an optimization that we would like to include. However, it was brought up that multivariate IOPs can often only support shifts and not rotations, and we couldn't actually think of any examples where rotations were strictly necessary, as opposed to just shifts. So we've decided that because we don't want to separate univariate and multivariate constraint systems, we will aim for an optimized Plonkish relation that supports shifts only. If it is the case that you happen to have a use case where this is going to be a problem, now would be a very good time to get in touch. We were also made aware of a paper called CLAP, which was recently released and could provide some pretty useful insights for us. They're also looking at Plonkish relations, and I believe their aim is to try and come up with something which is formally verifiable. Correct me if I'm wrong. I think the office might be in the audience. Am I wrong?
No, that's one of the...
Perfect. Okay, thank you very much.
Thanks. So the next working group we had was the Orrù compiler working group, which is like 2 layers beneath the Plonkish working group. So where we're at right now is that we have an abstract that's been approved, and we need to recruit people to actually write the draft specification. So this is kind of a recruitment call, as well as updating you on the progress. So those are the initial contributors who wrote the abstract, and we got a mix of people from academia and industry. And we outlined basically 4 categories that the draft specification should contain. So firstly, it's examining whether or not the IOP is compatible with the PCS. And there's several common features, such as whether or not you're using univariate versus multilinear, whether you have any minimum requirements on field size. We also want to preserve security guarantees in the Orrù compiler. So if your IOP is 0 knowledge, you should pick a PCS that is hiding. Yeah, we also considered efficiency recommendations, more on that later. And the deliverable, one of the deliverables of this working group will be a reference API and possibly a default implementation. So there's actually default implementations that exist in industry already. Artworks has this polycommit repo that has a polynomial commitment trait. And they've implemented it for, both univariate and multilinear PCS. Another example is from this repo, Plonkish repo. And similarly, it's generic over polynomial commitment schemes, and they've implemented it for IPA KZG hierarchs in both univariate and multilinear variants, as well as zero-morph breakdown and Gemini in the multilinear category,
So Artworks also has some PRs for hierarchs and breakdown in the
Oh,
almost
for hierarchs and breakdown?
yes.
Okay. And Ligero, right. Okay, cool. So our deliverable will be something like that. And so do join us in writing this spec if you're interested in seeing your PCS represented here. If you're interested in making sure that your PCS is compatible. So yesterday, we presented the abstract in the working group, and we discussed, most of the discussion was about the minimal assumptions that the IOP has to consider. I've mentioned some of these already. And also something interesting that was raised was sort of what's the difference between efficiency and compatibility. Like, for example, if we try to combine a univariate PCS with a univariate IOP with a multilinear PCS, would that be incompatible or just very inefficient? And what's the difference between those? So we sort of concluded that a scheme should document which choices of components is most efficient for it. And another good outcome from yesterday's session is we identified what's not in scope for this working group. So for example, this is a diagram from Hyperplonk that shows how many sub-IOPs can be composed into one larger IOP. And basically the Oracle compiler working group doesn't care about sub-IOPs, and we shouldn't see the sub-IOPs, we should only interface with the top level IOP. On a similar vein, we can assume that we are only using a single polynomial commitment scheme. I think this was a point from Dara Emma that if we do need multiple PCS, then we can express that as a commit and prove scheme. That's all I had.
Hello again. So I am the lead of the FIA Shamir and Sigma protocols working groups. Our approach is a bit different. We are planning to start from the simplest thing one person can imagine, Schnorr proofs and FIA Shamir, and then have something that people can use, and then reiterate over it after building also libraries that people can look into. So specifically for FIA Shamir, we have a technical report that I linked in the Telegram channel, but I'm also happy to hand out to you guys if you want in person. And where I think we figured out how to create a library that is compatible both with sponge functions as well as compression functions, so SHA-3, SHA-2, but as well as algebraic hashes. And I think there is a little bit of work also in the theory that needs to be done to bridge all of these with what we write in papers. And in particular, we have even implemented it in a library called Nimue that is compatible both with the traits used in Zcash, so like the group trait, as well as the traits used in Artworks. And it has example, it has sort of enough documentation for people to use. And I'm very also happy to announce that from Monday, we'll start having a review, a security audit over it. And so I think this is the process by which at the end, maybe we'll have a little bit less bugs and paper that come every 5 years showing how badly we're implementing FIA Shamir. We also have started a specification document, more in the format of the IATF. And I have a mailing list where you can join, where I plan to announce how it's developing. And throughout the meeting that we had yesterday, we sort of went through this and discussed a little bit more the details, and I gathered some feedback from you guys. As far as the Sigma Protocols Working Group is concerned, it's sort of one of the oldest working groups. By now, it's been there for a couple of years. We have already a specification, a draft of a specification in PDF that we moved into sort of the more IATF format. And I think this is going to be particularly relevant in the next years, because we have on the one hand the IATF that has been standardizing Schnorr proofs. Then with the World Privacy Pass, VOPRF, they already have to standardize DLEQ proofs. And you know, the W3C is standardizing BBS signatures, over which you will have to do Sigma protocols. So I think this is an excellent opportunity and timing for this, for getting this spec ready and people to use it. We got some funding from the European Union via the Next Generation Internet, and with this funding, I'm also happy, you know, to finance some parts of it if you're happy to be involved into this. And yeah, we also have a mailing list that's sort of the main way which we communicate right now, where I keep you posted of what's going on. That's pretty much everything for me. Thank you.
Okay. I guess we can start with some questions to the different working groups, standardization working groups. You have the opportunity here to have the actual people running those different groups. And if you're wondering at any level questions on how it operates, or you know, probably these type of questions that you have are shared by more than one other person next to you. So the threshold for questions is lower than you'd think. And I will wait 20 seconds until the first person raises their hand.
This is a question to Mary. For the Plonkish working group, what is the scope of proof systems that we want to be able to support? Or are we just standardizing strictly in arithmetization?
That's a pretty good question. You know, it's a good question. Ultimately, if we just have the arithmetization standardized and nothing else, probably it's going to be pretty hard for people to use that, or at least the people who really care about their scheme being standardized to use that, because they will have no proving scheme to work with it. At the same time, taking on the full stack, so I've previously described the stack rightly or wrongly as the constraint system, the optimizing system, the IOP, the Oracle compiler, the Fiat Shamir process, all in one working group. It's too much. We can't do all of that, and we don't want to do all of that. We want other people, other companies, other ways of doing things involved in this process. So our aim is to just tackle one chunk, do it as well as we possibly can, and then hopefully have some input from other working groups that are compatible, that are talking to us, that we're talking to them, but not necessarily the same specification, the same abstract, the same people, in order to make that happen.
I have a question over there. Daniel?
Yeah, hello. This is a question for Michele. Where are you? Oh, hello. Yeah, first of all, thank you a lot for the library, Nimue. We've been using Merlin, actually, in our repo for the Fiat Shamir transcripts and all of this. So this is really exciting because we can try it out. I guess just generally, like, what is the motivation for doing it? Is it mainly compatibility with ArcWorks? And does it improve on anything?
No, matter of fact, you could use Merlin with ArcWorks. That's what I did with Gemini myself. Right. There are two main things that I think need to be handled in Merlin and that they are not, and actually three. Well, first of all, Merlin has not been maintained for many years now.
Yeah.
But also Merlin is based on the Strobe framework. So the Strobe framework is this framework from Mike Hamburg that helps you encode data structures in a wire, and is extremely byte-oriented, and the hash function has been fixed. One of the sort of discussions that happened in the past year was also, well, if we do Fia-Shamir, we're going to have to deal also with algebraic hash functions. And good luck encoding Strobe in field elements. In the meantime, other proposals came out, like the Safe API and Signal had done private groups with a strategy for encoding compression, for putting Fia-Shamir with, making Fia-Shamir compatible with compression functions. And I think these two avenues were auxiliary and sort of helped sort of direct a way that is more generic than what Merlin allows. There is a second problem, and that I think is really important, is that Merlin really doesn't care about. Everybody should specify their own way of encoding data outside of the byte level. And this can be also problematic. One of the features of Merlin is that you can, at least they claim that you can compose protocol nicely, so you just have the hash state and you just put it in different functions. However, when you write a transcript with Merlin, you'd never put the last message. If you have a Sigma protocol where it's not unique response, where you have many messages, then composing transcript does not work as nicely. And so you see, maybe you get the intuition of what I mean. But so like you really have to be careful with these things. And that's also, I mean, why we're specifying things.
Yeah,
so,
no,
yeah, that's the reason.
That's awesome. That's super helpful. And why Nimue?
Because it's the daughter of Merlin. I think he had sort of a crush on her. And sort of, yeah. And then she killed him. And,
oh no. Okay,
cheers.
Thank you. Thank you.
All right, Mutu, do you want to come over? So in addition to the working groups, we had next door also sessions, just more general sessions that couldn't be here. And you were actually moderating those sessions. So tell us what happened.
Sure. I'll just warn a little bit that, you know, I have a lack of sleep, not just because of jet lag, but also I have a 7-month-old baby, and so I might have forgotten several things. So, you know, people in the session, please, you know, call me on the things that I've forgotten. So where was I? Thanks. We started, I mean, it was an open session. We wanted to ask what kind of things that we, you know, are in the top of the minds of people who came there. The first was understanding the scope of recent techniques like incrementally verifiable computation, recursive composition, and also, say, ligatron. What kind of applications are going to take advantage? Are there like specific, like IVC, is it good for certain kind of applications? You know, we had some discussion that kind of evolved into also understanding how do we benchmark these systems, and also understanding that with approaches that decompose computations and, you know, compose them back, how do you think about the witness? Like, does the witness have to go to all the different entities? Can it go to some of the entities? Can we compose? There are different challenges, like how to again, weigh those versus like what choice to make. I don't think we came into any conclusion, but I think these are interesting questions as these techniques are getting developed. Another question, maybe a little bit more about the benchmark. Here is one way, I think, this was my proposal, and again, you know, if someone has you know, something different, you know, feel free to propose, is to, I think more from the ZKVM side. So for me, it's like cycles, CPU cycles, to understand the overhead of these computations. So take your native program, convert it to whatever favorite VM, and estimate the number of CPU cycles or instructions for insecurely natively running this computation. And then for proof systems, I mean, more or less, most proof systems follow the polynomial IOP or IOP method, and the biggest part of the computation typically is committing to these values. Now, you have many intermediate representation, arithmetizations, and so forth, but finally, when it comes down to your oracle, there are so many values that you commit. So count the total number of values that you commit and divide it by the number of instructions. This gives some sense of the overhead. It, of course, ignores, are you using a public key-based commitment scheme to implement, like KZG, or are you using hash function based? I do think this ratio is still a good number to think about it if you can interchange how you're going to instantiate your oracle. And the last thing, kind of what we were discussing, and we ran out of time, and I actually literally ran out of the session because I had to come here to talk about, was just the complexity of, say, arithmetization using Plonkish. There are, good things and there are, bad things, as well as, like, on the other side, ideally, what would you like DSLs or embedded DSLs, and we kind of talked about, where should we be? How should we, think about these things? And also a larger discussion, which again, this is probably more my opinion than the whole group, is like, I feel like there is ZK VMs on one end and like specialized circuits, or like, even, I don't want to call it specialized, but, the arithmetization that we see today. And there is a question on, hey, like, ZK VMs, for example, Orrù's presentation said every instruction goes to, maps to 80 constraints. Independent of what the instruction is, could be add, could be XOR, it gets mapped to 80 constraints. And it was the sort of opinion of the room that that is high, right? And at the other end, like, you can code things in Halo 2 and so forth, which are pretty efficient. Now, how are these going to converge? How is it going to look like? And of course, I'm on the camp more on the VM side, but this is, I think we have to wait and see how things evolve.
Thank you very much. Okay. Mary, do you have concluding words for this part of the conversation, or?
Mostly, thank you.
Okay, awesome. We're going to immediately continue to the second part, which is a sort of summary of the event. What we're going to try to do is have random people in the room tell me and us what is the highlight for them from the past 3 days, and what do they remember? What got top of mind as far as they're concerned from everything that we've seen here. I must say that this year we had so many talks, and I want to thank you again, by the way, for the work of the program committee, you and Kermit, and all of the reviewers. Thanks again. Again, it's not sure if we should or should not publish the background conversations on the papers. They were very interesting. So I got comments that this year's event is very academic, and I usually see it as a good thing, because there's not enough, places to go deep into those discussions, and this is part of what we strive for. But that comment was made in the sense of, we have an industry agenda, and maybe it's a tiny bit too academic for us from the point of view of us being, practitioners of, let's say, never mind names, but, and that's an ongoing tension or question of where we put the balance in terms of what you are coming to see. Do you enjoy the drill downs? Do you enjoy the demos and sort of the balance? So with that in mind, I have my personal opinions, and as teams we have our personal opinions each. But I want to ask, again, randomly, who wants to give their thoughts about these past 3 days? Raise your hand really high. Everybody raise the hand. Okay. I'll start with you.
Thanks. So my answer is like, fear not. I think it's academic enough, but I think it's very nicely balanced. That's my observation about the last 3 days, frankly. So yeah, at first it seemed a little bit too much on the academic side, but it sort of rebalanced itself over time. And again, a bunch of people, myself included, straddled the kind of industry academic divide as well. And you know, there were conversations late into the night with people running startups in this space. So frankly, like if I think about both the kind of academia versus industry, but also like, you know, do we have too many conference-style talks versus like open-ended discussions or sort of idea pieces or proposals or demos even, let's say. I think it's also like a very nice kind of collection of these things, right? So nothing is too dominant, I would say, which is also quite nice. And frankly, the other thing is that 3 days to me is probably sort of the right amount. I think you get a chance to speak to a bunch of people, and like, I don't know if you've been to Dagstuhl. There they have a practice of reshuffling you at every meal, so you get to speak to pretty much everybody after about 4 or 5 days. That's right, that's right. It seems to have happened more or less naturally here as well. So I feel like I've spoken, maybe not to everybody, but to quite a significant number of people as well. So, but like beyond 3 days, I probably wouldn't go either. Probably would be a bit too long, right? So there's clearly some competition like ZK Summit out there, and that's extremely well attended in the last, you know. Yeah, no, I think it's a great event. I believe they had about, what, 300 people, 350 people last time around. So yeah, it's a massive thing. But yeah, there is every reason to have these kinds of events as well. And this is a nice counterpoint as far as I'm concerned.
Do you have any highlights in the sessions?
Well, the session we had, I mean, I don't know, there are just kind of interesting connections that have come out from just about every session, and you know, interesting things to follow up on, and the connections that come out of that. That's to me one of the more valuable aspects of it.
Yeah, I really enjoyed it. Made some new connections and friends, which is always nice. The contacts with the PAYY, I'm not sure how you pronounce that, just pay, people. And let's see, I came away enthused at writing circuits in Lean. I really like Lean. Well, I think I will like Lean because it's dependently typed languages take quite a while to learn.
Lean, you're saying?
Yes.
Lean 4?
Lean 4. I think, and I completely endorse Ben's comments. I think the balance was just right in my opinion.
Who else?
Yeah, so I think the balance was good. Yeah, I like to, after being randomly selected, say a few words about the highlights for me. I don't have a 7-month-old baby, but I didn't bring enough pants to Berlin, so you might have had a really good talk, and I was just out buying pants, if I don't mention you. Yeah, like one thing I really liked was Jonas's talk about sort of the state of integrating ZK into Bitcoin and the obstacles, the different options. I thought that was a really good summary of the different like issues if you go back and watch that talk. And it was nice to have it followed by sort of, I think, the most popular attempt right now to get programmability into Bitcoin BitVM by the creator. So that was pretty nice. I guess also in terms of like academia versus industry, I really like the talk about proving Plonk, well, I guess Plonk and Marlin secure and the sort of the exact instantiation people use with the linearity trick originally by Mary. And I liked having a talk about basefold because it's just been one of my favorite papers in the last year and a half. What else do I want to? I like the voting talk for the first day. I think it's a nice sort of application of, or massaging of lookup protocols, where you sort of need to prove that a bunch of witnesses, their union is exactly the elements of the table without repetitions, and that gives you sort of that everybody voted and everybody voted once, and what else? Yeah, I think an interesting issue that has come up for me working with Aztec this last year, and also came up, I think, in Jens's keynote and in the talk about Nova security today, is there's the IVC notion is very popular and useful. But there's this little thing that in the classical IVC, if you look at Paul Valiant's paper, he's talking about a computation humanity is doing throughout centuries, and we don't know the endpoint, but in real life, in many applications, we know the endpoint. We're like maybe folding a certain computation of a certain length, and yeah, I think both in what Jens was talking about and in the new way this paper is proving the Nova security for a polynomial rather than logarithmic number of steps, you sort of use this thing that you do know the endpoint. And I was playing actually last month for a possible name of this instead of IVC. You could maybe call it repeated computation, just sort of maybe another term to emphasize that you do know the endpoint, and you're going to take advantage of that. I enjoyed the Plonkish working group. Yeah, I assumed in the beginning it was going to be about taking a very specific instantiation, a specific gate, and how to exactly implement that. Sort of similar to standards I've seen of signature schemes, where it's about the details of how to implement it exactly. And sort of like Dara asked, maybe there's a room for, or Mary answered, there's maybe a room for a parallel or a subsequent effort of something like that. But yeah, I really enjoyed seeing that the standard is going into really into the depth of all the possibilities of this type of arithmetization. And yes, and I was during all other talks I was out buying pants, so that's all I have to say. Thanks.
Interesting. All right, just a moment.
Thank you, Jonathan. Yeah, following on the balance between just industry and academia, I also resonate with what Ben said. I think it's very well balanced. Speaking from the industry folks from Nexus, or our hope is to sort of say thank you to all of the people that have been researching all of this, right? Like the artworks contributors, to the people working on the Plonkish standardization, and many things that have come before this. And so it's sort of like our attempts to some degree is to say, well, thank you, right? Thank you for everyone that has allowed us, as humanity, to reach this point, and the many things that will come through. So my hope is that, I know by bringing a little bit of industry, it can be motivating, hopefully, for all the great people that are working on this field. And so my hope is that, yeah, hopefully that can continue for the next versions of ZKProof.
Yes, do you have something to add?
So I guess I would sort of look at from with the hat of steering committee member on, right? So the question I was asking myself is, are we as a community making progress? And I was comparing with the program we had last year, right? So that was a year and a half ago. We had ZKProof 5, right? And it's so interesting to see then what is the delta we have achieved in between there, right? And how would we measure what is the progress that we're making, right? So since then, we had in Alessandro's talk, he and together with Elon, they've written a book, right? So we have an extra book now that talks about the random oracle model, right, and how to build succinct proofs from random oracles. So I think that's one step ahead. I like Matteo's talk about how do we actually measure performance, right? It's very vague and fluffy because it is a difficult task to do that. But we actually have an example of that because in ZKProof 5, Karmit gave a talk about ligatron, and today Muzo gave a talk about it, right? And you can actually see that on a personal note, so I noticed ZKProof 5, Francois was saying Groth 16 is still alive. At this workshop, Costas was saying Groth 16 is still alive. Now we have, we are thinking about standardizing Groth 16, so maybe there will be a vote at the next one whether it's still alive. So, but I don't know, I think it's, of course I'm very happy, and proud to see that this is the choice.
Groth 32.
Yeah, and I think then one thing I think has always when we had the first ZKProof conference, right? We were we wanted to standardize things, but we didn't quite know what does standardization even mean, right? It's and I think it's a question that's been throughout the ZKProof workshops. It's been we want to do something, we don't quite know, how do we make some progress, and we make some small steps ahead, right? And I think we've taken a bigger step than usual at this conference with the working groups, right? And I think it will be, maybe this is the metric to use at the next ZKProof, right? Then what has come out of that process, and when we're actually starting to see some standards coming out of this whole process.
So who else has comments or highlights that they want to? One minor thing.
Yeah, someone thanked, I think the person from Nexus thanked members of the working groups. Some of them are not here. So for example, Strad on the Plonkish working group has made some really important contributions to that specification, or draft specification.
Huge contributions.
Shout out for Strad for huge contributions. Thanks. Okay. So I wanted actually to react about the the different schemes that we're seeing and the delta between ZKProof 5. Right before we started the conference, there was a little bit of a hype cycle on BNews, and there was no BNews in this conference explicitly, where it was mentioned with the Jolt people, and this is strictly because that team was coming back from Berlin to the US, and it did not make sense to do the back and forth to come be here, but they wish they could. So I think we see that, yes, there's a lot of progress, and year after year we see more and more techniques. But we are lucky to have teams that dive deep into the existing techniques to figure out what can be eventually made into a standard. And also, it is true that we have a higher bar now for the next ZKProof, because we write a sort of promise here. Working groups are going to progress. Formal verification efforts are going to move forward. We will need to check, our future selves. Did we accomplish what we set out to accomplish? And it's not small feats. So I think I want to have Muthu back here and just slowly morph into the conclusion of these 3 days. So it's very simple. The first and foremost, I wish to thank the KEDIT team, and in particular Liad over there. Liad, you rock, you kick ass, and thank you so much for organizing all of this. I know that, some of you are in the academia, some of you have commercial entities, and you always count on your teams to move things forward. But this event was something special. I asked Liad to do as much as she can so that I don't get involved in the organization, so that it stands a chance to succeed. And that is a resounding success. So really thank you, and thank the rest of the KEDIT team for putting all the effort. We're not a big team, and this is really a moment for us in the year where we really focus efforts. So that's like the obvious one. It's not a lot of people to thank. It's really a core team. The next very obvious one is the sponsors, which made this thing possible. So big round of applause to all of our sponsors, and I'm going to name them. We have the guys from Misten Lab, that's Sui. We have Casper, we have InverseTech. InverseTech, you guys know, InverseTech is Daniel Benaroche and his team. That's the guy that started ZKProof back in KEDIT, and now he's thriving, doing zero-knowledge proof and other techniques, also with WorldCoin. We have Nexus, we have ZK Sync, so Matter Labs. Some of these are like the commercial brand and the company. And then we have the Ethereum ecosystem support program. We have Gevulot. We have Ligero, thank you so much. And we have Open Zeppelin. All of these were actively sponsoring, meaning it wasn't just, we want our logos and merch. This was genuine help on how to make sure that this works out from the beginning to the end. So a huge thank you to all of these sponsors. This is what makes it possible to run these events. Again, thank you. And so finally, I come back to you. I said it throughout the event, but the quality of what we got, and the speed and ease in which the program committee functioned was really the core of what we saw. I'm talking to you, but through you, you join me to thank the people.
Maybe just a word about the program committee. Actually, I should say, as the chairs for Karmit and me, the job was remarkably simple for 2 reasons. We got really amazing people to serve on the committee, but also got amazing papers, So it was really a completely win-win. So my side of it was really was very easy. But I should also say that we should have a round of applause for John, like for organizing this whole event. Like I've watched him, like how he's like from conception to here, the amazing amount of effort. And I also think I want to acknowledge, considering the, the situation in Israel and how they are still able to, contribute to this event. And also, so a big round of applause for John and Kevin. So just following Jens also, like I think being on the steering committee, I do want to say that like I think the ZKProof is flourishing a lot because of the community. It is, I think there is dedicated effort from Mary, from Dara, from all the people in the working group to push this forward. And I think really it's the community that is pushing this forward. One comment I will make about what John asked at the beginning in terms of talks being technical versus this, I think it's a cycle. I mean, there are important things like IVC is trying to solve an important problem. Basefold is trying to solve an important question. And, whatever questions are, these are strongly motivated from practice. And I think even though they were technical, I think the difference between these papers and the ones that go to, traditional conferences, even though they were theoretical, I think I really love it that it comes from a very strong motivation. I'm an academic. I like doing theory for theory's sake. But when I come here, I love the theory that comes from, from the real world.
Okay. See you on the next one. Thank you very, very, very much. This seals the whole event. Thank you.